Welcome to Technology Comparisons Crashcasts. I'm your host, Sheila, and today we're diving into a hot topic in the world of distributed systems, Kafka versus RabbitMQ. Joining me is our expert, Victor. Are you ready to break down these powerful message brokers, Victor?
Absolutely, Sheila. I'm excited to explore the differences between these two popular technologies and help our listeners understand when to use each one.
Great. Let's start with a quick overview of what we'll cover today. We'll discuss the history of Kafka and RabbitMQ, their architectures, use cases, scalability, performance, data persistence, message ordering, and much more. But before we dive in, I've got a quiz question for our listeners. Ready?
Bring it on, Sheila. I'm sure our listeners are eager to test their knowledge.
All right, here's the question. Which of these two technologies, Kafka or RabbitMQ, was originally developed by LinkedIn? Take a moment to think about it, and we'll reveal the answer later in the show. What do you think, Victor? Any hints?
Ooh, that's a tricky one. I wouldn't want to give away the answer, but I will say that the origin of these technologies often surprises people. It's fascinating how companies develop internal tools that end up becoming widely adopted in the industry.
Excellent point, Victor. Now, let's start with the basics. Can you give us a brief history of both Kafka and RabbitMQ?
Certainly. RabbitMQ was developed first, released in 2007 by Rabbit Technologies Ltd., which was later acquired by SpringSource, a division of VMware. It was designed as a robust message broker implementing the Advanced Message Queuing Protocol, or AMQP for short. Kafka, on the other hand, was developed by LinkedIn in 2011 to handle their real-time data feeds and stream processing. It was later open-sourced and became a top-level Apache project in 2012.
Interesting. So RabbitMQ has been around longer. Before we go deeper, could you explain what a message broker is for our listeners who might not be familiar with the term?
Of course, think of a message broker as a digital post office for your data. It's a software that enables applications, systems, and services to communicate with each other and exchange information. The broker receives messages from senders or producers and routes them to the appropriate receivers or consumers. This setup separates the sender and receiver, allowing for more flexible and scalable system designs.
That's a great analogy, Victor. So, if I understand correctly, both Kafka and RabbitMQ serve as message brokers, but they have different architectures. Could you elaborate on that?
You're absolutely right, Sheila. While both serve as message brokers, their architectures are quite different. RabbitMQ follows a more traditional message queue architecture. It's designed around the concept of exchanges and queues. Publishers send messages to exchanges, which then route these messages to queues based on predefined rules. Consumers then read from these queues. Kafka, on the other hand, is built around the concept of a distributed commit log. It uses topics, which are divided into partitions. Producers write to these partitions, and consumers read from them. Kafka maintains these partitions across a cluster of servers, allowing for high scalability and fault tolerance.
That's fascinating. It sounds like they have quite different approaches. Could you give us some examples of when you might choose one over the other?
Absolutely. RabbitMQ is often a great choice for traditional queuing scenarios, where you need features like complex routing, per-message time to live, and priority queues. It's well suited for applications that require low latency and need to ensure that each message is processed exactly once. Kafka, on the other hand, shines in high-throughput scenarios, especially when dealing with event streaming or log aggregation. It's excellent for building real-time data pipelines and streaming applications. Kafka is often chosen when you need to process large volumes of data, replay streams, or build data-intensive applications.
I see. So it really depends on the specific needs of your system. Now, I've heard that scalability is a big differentiator between these two. Is that true?
That's a great question, Sheila. Both Kafka and RabbitMQ can be scaled, but they approach scalability differently. RabbitMQ uses clustering for high availability and can scale by adding more nodes to the cluster. However, all nodes in a RabbitMQ cluster have a copy of all the data, which can limit its scalability for very large datasets. Kafka, on the other hand, was designed from the ground up for horizontal scalability. It partitions data across multiple nodes in a cluster, allowing it to scale to handle massive amounts of data and high throughput. Each Kafka broker can handle terabytes of messages without performance impact.
Wow, that's impressive. It sounds like Kafka might be better for really big data scenarios. But what about data persistence? How do they compare in that aspect?
Great question. Data persistence is indeed handled differently in these two systems. RabbitMQ is primarily designed as a memory-based broker with the option to persist messages to disk. By default, messages in RabbitMQ queues are stored in memory and only written to disk when under memory pressure. This approach provides low latency but can potentially lead to data loss if there's a crash before messages are persisted. Kafka, on the other hand, is designed with persistence in mind. All messages are immediately written to disk and replicated within the cluster for fault tolerance. Kafka retains all published messages for a configurable period of time, regardless of whether they've been consumed. This makes Kafka particularly good for event sourcing and replay scenarios.
That's really interesting, Victor. It seems like these differences in persistence could significantly impact how these systems are used. Now, I'm curious about message ordering. How do Kafka and RabbitMQ handle that?
Excellent question, Sheila. Message ordering is indeed handled differently in these two systems, and it's an important consideration for many applications. In RabbitMQ, messages published to a queue are typically delivered to consumers in the same order they were published. However, when you have multiple consumers on a single queue, the order is only guaranteed per consumer, not across all consumers. Kafka, on the other hand, guarantees order within a partition. Messages sent by a producer to a particular partition will be appended in the order they are sent. Consumers reading from a partition will receive messages in that same order. However, if you're consuming from multiple partitions, there's no guarantee of order across partitions.
I see. So in both cases, you need to be aware of how you're consuming messages if order is important. Now, let's talk about some common misconceptions or pitfalls when using these technologies. What should our listeners be aware of?
Great point, Sheila. One common misconception is that Kafka and RabbitMQ are interchangeable. While they're both message brokers, their strengths lie in different areas. A common pitfall with RabbitMQ is underestimating the impact of large queues. If a queue grows too large, it can impact performance and even crash the broker if it runs out of memory or disk space. With Kafka, a frequent mistake is not properly configuring partitions. Too few partitions can limit parallelism and scalability, while too many can increase overhead and make management more complex. Another pitfall for both systems is not properly handling errors and retries. It's crucial to implement robust error handling and consider what happens when a message fails to be processed.
Those are great points, Victor. It's clear that proper understanding and configuration are key to successfully using these technologies. Could you share some best practices for implementing Kafka or RabbitMQ?
Absolutely, Sheila. For both systems, it's crucial to monitor your brokers and queues or topics closely. This helps you catch issues before they become critical. For RabbitMQ, first, use durable queues and persistent messages for important data. Second, implement backpressure mechanisms to prevent queue overload. And third, use separate queues for different types of messages to improve manageability. For Kafka, first, choose the right number of partitions based on your expected throughput and consumer parallelism. Second, use appropriate replication factors to ensure data durability. And third, regularly update and tune your Kafka clusters to benefit from performance improvements. For both, first, implement robust error handling and retrying mechanisms. Second, use meaningful names for your queues or topics to make your system more understandable. And third, consider using dead letter queues or error topics to handle messages that repeatedly fail processing.
Those are really helpful tips, Victor. Now, could you share some real-world examples of companies using these technologies?
Certainly. RabbitMQ is used by many companies, including Mozilla, VMware, and Pivotal. It's often used in microservices architectures for inter-service communication. Kafka, given its origin at LinkedIn, is naturally used extensively there. Other major users include Netflix for real-time monitoring and stream processing, Uber for collecting user, driver, and trip data in real time, and Spotify for log delivery and stream processing.
Fascinating. It's amazing to see how these technologies are powering some of the services we use every day. Now, I think it's time to reveal the answer to our quiz question. Victor, would you like to do the honors?
I'd be happy to, Sheila. The answer to our quiz question is Kafka was originally developed by LinkedIn. As we discussed earlier, Kafka was created at LinkedIn in 2011 to handle their real-time data feeds and stream processing needs.
Thanks, Victor. I hope our listeners got that right. Now, as we wrap up, let's summarize the main points we've covered today. First, RabbitMQ and Kafka are both message brokers, but with different architectures and strengths. Second, RabbitMQ is great for traditional queuing scenarios and complex routing, while Kafka excels in high-throughput event streaming. Third, Kafka is generally more scalable for very large datasets. Fourth, RabbitMQ offers more flexibility in message persistence, while Kafka is designed for long-term persistence by default. Fifth, both systems have different approaches to message ordering, which can impact how they're used. And finally, proper configuration and understanding are key to successfully implementing either technology. If we had more time, we could have delved deeper into topics like exactly once processing, security features, and integration with other technologies in the big data ecosystem. Victor, thank you so much for sharing your expertise with us today. To our listeners, if you enjoyed this episode, please subscribe to Technology Comparison's Crashcasts and leave us a rating. Your support helps us continue to bring you in-depth technology comparisons. Until next time, keep exploring and happy coding.
It's been a pleasure, Sheila. Thank you for having me, and thanks to all our listeners for tuning in.